Recall that before looking at limits, we started looking at the idea of the average rate of change of a function on some interval a to x. So remember that this was just the change in the function value divided by the change in whatever the x value was. And so we would find f of x minus f of a and divide it by x minus a. Now previously when we tried to use the average rate of change to calculate the instantaneous rate of change, we approximated the instantaneous rate of change by calculating the average rate of change on smaller and smaller intervals. Around whatever x value we're looking at. So we'll call it a. So smaller and smaller intervals around a. So then our instantaneous rate of change for a function then would be the limit as x approaches a of this f of x minus f of a all over x minus a. And so basically what we're doing is we're finding the limit of the average rate of change as x goes to a. So this is going to be something that we are going to be using a lot actually, which is called a derivative. So definition: the derivative of a function f of x at a is the limit, assuming it exists, f prime of a is how we're going to go ahead and denote the derivative of a function at a value a, and this is the limit as x approaches a of f of x minus f of a all over x minus a. Now this isn't the only definition you can use for the derivative. An equivalent definition would be f prime of a equals the limit as h approaches 0 of f of a plus h minus f of a all over h. And so essentially this slight rewording is just replacing the x minus a with h. And so what this does is it basically describes okay, as we're getting our function values closer and closer to this f of a, and we're shrinking this gap to 0, what's happening? So you can use either of these formulas. Either one of these will get you what you're looking for. In some cases, one of the limits may be a little bit easier to calculate than the other. So if you're stuck trying to do one method, try switching to the other method, or vice versa. Okay, now there are a couple of ways for us to go ahead and interpret the derivative. So first is that f prime of a is the instantaneous rate of change of the function f of x at x equals a. Another way to think about it, though, is that it is the slope of the tangent line to f as x equals a, or at x equals a, rather. So here, if we're looking at this function down here, we've got this dotted line. This dotted line is the tangent line to f at x equals 4. So what we're saying then is the slope of this line is the instantaneous rate of change at x equals 4. Or in other words, that's f prime of 4. So let's go through an example of trying to go ahead and calculate this. So let's say we've got a function. Oh, my thing seems to have frozen. Okay, we're back. Let's say we've got a function f of x equals 2x squared minus 5x plus 1, and we want to know what f prime of some number is. So if we say f prime of a, then that lets us go ahead and figure out what a will be later. And then we can go ahead and find it for a particular a. So if we plug in letters, f of a is going to be 2a squared minus 5a plus 1. And to be clear, we're going to use the definition f prime of a equals the limit as h approaches 0 of f of a plus h minus f of a all over h. Now, I recommend that when you get through this example, try the other method and see if you get the same result, because the derivative, whichever method you use to calculate it, will be the same. So this is f of a. So we also need f of a plus h, so that way we have all the pieces for our formula. And so this will be 2 times a plus h squared minus 5 times a plus h plus 1. And so this might be helpful to expand out, and for this to be multiplied through so we can start combining some terms. So this is going to be 2 times the quantity a squared plus 2ah plus h squared minus 5a minus 5h plus 1. Now if we multiply this 2 through and then start combining like terms, we should get 2a squared plus 4ah plus 2h squared minus 5a minus 5h plus 1. So there's not really any like terms for us to go ahead and combine just yet. So if we want to find f prime of a, it'll be the limit as h approaches 0 of 2a squared plus 4ah plus 2h squared. And so to be clear, what we're doing is f of a plus h minus f of a. So we'll take this thing we found for f of a plus h, so minus 5a minus 5h plus 1, and then we need to subtract f of a, which is this. So this is 2a squared minus 5a plus 1. And so this will all be divided by h. Now remember, we can't go ahead yet and plug in the h directly, because if we plugged in the h directly, here we'd be going, since we're going to 0, we would have a problem because we'd be then dividing by 0. So since we can't do that, we want to go ahead and combine our like terms first. Now what I'd recommend doing is distributing this negative sign and making it very clear what's being subtracted and what's not. So minus 2a squared plus 5a minus 1. And then we'll go ahead and try to start combining some things. So we'll have 2a squared and negative 2a squared cancel out, negative 5a and 5a cancel out, plus 1 and minus 1 cancel out. And so this leaves us then with the limit as h approaches 0 of 4ah plus 2h squared minus 5h. And that's all we have left up here. So it may help when you're doing these to kind of circle the ones that didn't get crossed out, so that way you don't forget about them. And this is divided by h. So remember, if we want to take out an h, essentially what we're going to do is divide each of these terms by h. Or we can think about it as factoring. So limit as h approaches 0 of h times 4a plus 2h minus 5 all over h, then this will mean that our h's will cancel. We get the limit as h approaches 0 of 4a plus 2h minus 5. And at this point, since we don't have any dividing by 0 things to worry about, we can go ahead and plug this in. So h will be 0, so this will just be 4a plus 5. Okay, great. So that means that even without specifying what our value is going to be to input into this, we now know what it is that we're looking at for our derivative. So if I then said f prime of 3, what this is saying is that I want the derivative when a equals 3, or when x equals 3. And so this will just be 4 times 3 plus 5, or, oh, I screwed up, this should be a minus 5. And so we'll have 4 times 3 minus 5, so that'll be 12 minus 5, which is 7. All right, next we can go ahead and find the equation of the tangent line at x equals 3 for this function. So same function as the previous example. So in order to find the equation of the tangent line, we need two things. We need a point on the line, so that way we can find the y-intercept, and we need the slope of the line. Now, the slope of the line, we actually know. It's f prime of 3, so it's just whatever the derivative is at that point, and we just found out that it's 7. Now, a point on the line that we know, if we're trying to look at the tangent line at x equals 3, we'll have the point 3 f of 3. Now we don't know what f of 3 is offhand, but we could very easily find it. So remember that when you're looking for the equation of a tangent line, we usually look at y equals mx plus b, where m is the slope of the line, and x and y are going to be whatever the x and y value of any point on that line is, and b is the y-intercept. So let's fill in some of the things we know. We know that f of 3 is going to equal 7 times our x value of 3 plus b. So remember, the 7 is coming from the derivative. So then the question becomes, what is f of 3? Well, we know that our function is 2x squared minus 5x plus 1. So we'll have 2 times 3 squared, since 3 is our x value, minus 5 times 3 plus 1, and we'll get 4. So 4 will equal 7 times 3, which is 21, plus b. So if we subtract the 21 over, we get that b will equal negative 17. And so that means that our equation of the tangent line, is going to be y equals 7x minus 17. So again, 7's coming from the slope of the line, negative 17's coming from what we found the y-intercept to be. Alright, so now we can also go ahead and try to find the equation of the tangent line, not necessarily at, in general, any a. We could go ahead and start by finding it at a specific a. So let's use the function f of x equals x plus 1 over x to try to find the tangent line of the function at a equals 1. So first thing we want to do is recognize the things we need to find. We want the point 1 f of 1. And so when we look for 1 f of 1, we see that this will be 1 plus 1 over 1, so we have the point 1, 2 for our line. The other thing that we have to look at is we also need to find the slope f prime of 1. Okay, so say we want to find this f prime of 1. In order to find f prime of 1, we're going to use the limit as h approaches 0 again. Definition. This will be the limit as h approaches 0 of f of 1 plus h minus f of 1 all over h. And so all we're doing is we're taking 1 plus h and plugging it in anywhere we see an x. So this will be the limit as h approaches 0 of 1 plus h plus 1 over 1 plus h minus, now we know that f of 1 from up here is going to be 2 over 2 all divided by h. So this is going to be a bit of a difficult one to figure out because we got a fraction up here. And so our method is going to be to go ahead and multiply the numerator and the denominator completely by a factor of 1 plus h. So that way we can go ahead and remove this 1 plus h from this denominator. So now I'm going to bring this over here. We get the limit as h approaches 0 of 1 plus h squared plus 1 minus, if we distribute the negative 2 through, we'll get minus 2 minus h, minus 2 and minus 2h. And this will be all over now h times 1 plus h. Okay, so again, we've got this nice squared term here that we're going to have to go ahead and expand. So this will then be the limit as h approaches 0, and we want to go ahead and FOIL this out. So we'll get 1 plus 2h plus h squared plus 1 minus 2 minus 2h all over h times 1 plus h. Alright, so right, we've got everything right at this point. We can go ahead and cancel some stuff. 1 plus 1 is 2, but we also have a negative 2. So these two 1s will cancel with this negative 2. 2 plus h and negative 2 plus h are going to go ahead and cancel out. So that means we're left with the limit as h approaches 0 of h squared over h times 1 plus h. And now we can go ahead and cancel some stuff. So this h will cancel with one of these h's from h squared, and we'll just be left with the limit as h approaches 0 of h over 1 plus h. And so this means we'll end up with 0 over 1 plus 0, which is just 0. Great, so this is our f prime of 1. This is our derivative when x equals 1. So then the equation of the tangent line, when we go to try to find this, what we're doing is we're taking the slope and the points. So normally, again, y equals mx plus b. Our slope is 0, so we really have y equals b, or just 0 plus b. So plugging in our point then, b equals 2. And so in the end, the equation of our tangent line will just be y equals 2, since our slope is 0. Alright, so now we've got this, so that's great. We can find a tangent line's equation. So given that the derivative of the function f at 1/2 is -3, we want to know what the tangent line for it's going to be. So again, we need just the slope. So we found the slope of the line. But we still need the point 1/2 f of 1/2. So again, if we want to find f of 1/2, what we need to do is we need to take our function from before and plug in 1/2. So now we'll take 1 over 2 plus 1 divided by 1 over 2, and we'll get 2.5. So we get 0.5, 2.5. And so if we're going to go ahead and try to find our equation of our tangent line, again, y equals mx plus b. So plugging in what we know for x, y, and m, we'll get 2.5 equals negative 3 times 0.5 plus b. So 2.5 will equal negative 1.5 plus b. And then adding the negative 1.5 over, we get that b equals 4. So the equation of the tangent line then will be y equals negative 3x plus 4. All right, let's do one more example. So say we've got a certain number of bacteria after T hours in some controlled laboratory is going to be equal to some function value.